So we have seen equations that look like, you know, maybe this. So we have only one variable. And when we solve these, we usually have exactly one answer. Not always. Sometimes our answer is all real numbers. Sometimes there's no solution that works. But typically we have one answer. There's one value for x that makes that true. This video today, we're going to talk about solutions to linear equations. And in a linear equation, we have equations that have two variables in them. And in these, there are infinitely many solutions, but it's not any old number, right? So we're going to need a value for x and a value for y. And for each value of x, there's exactly one value for y. And let's see what these look like. So if we had the linear equation y equals 2x plus 1, and just as a side note, you will also see function notation used. You'll see f of x. That's how we read that, f of x. That is just a different way of writing y. The advantage of function notation is if you had a point like from this table, if we had a point 2, 5, instead of saying when x is 2, y is 5. That whole thing can be written much shorter if we say at 2, the function when x is 2 is equal to 5. This tells me what my x is and my y, or my f of x at 2. So if you see that f of x and you get confused, it's just the same. It's just another way of writing y. Anyway, so we can have these in graphs, we can have these in tables, we can have these in equations, and you should be able to see how we have multiple possible answers, right? 0 for x and 1 for y is one possible answer. 1 and 3, 2 and 5, 3 and 7. And you can see these same points on the graph: 0, 1, 1, 3, 2, 5. We even have these guys down here, huh? -1, -1, -2, -3. We have tons of solutions. And if we didn't even mind using a decimal or fraction, we've got even more. Every single spot on this line is a coordinate answer, a value for x and a value for y that makes this equation true. So we have multiple ways of finding these solutions. I'm going to show you a couple ways. One thing is we're sometimes asked to validate a solution. Does this solution actually work for this equation? And the way we do that is we're going to plug these in. Remember, it's always x and then y. So we're going to take our equation and just instead of x and y, we're going to put in these numbers. So 23 was y and 10 was x. And now we're saying, is this really going to work though? So we're not really sure if it's equal. And we're going to find out. So we've still got 23 over here. On this side, I'm going to do 2 times 10. And then I'm going to add those together. And I want to say, is it true that 23 equals 21? No. So this is not a point on the graph. It is not a solution to y equals 2x plus 1. Let's try 511. So we're going to put in, again, our points for x and y. So 11 equals 2 times 5 plus 1. And we're saying, does it equal that though? 10 plus 1 is equal to 11. Absolutely. This one does work. So yes, 511 is a solution. Fantastic. It'll be on the line on the graph, and it's going to also, if we plugged it into the equation, it works. If we had a table, it would be on the table. When you are given a value and you're trying to find the other part of that coordinate solution, you're basically just going to take the number you have and plug it right in for whichever is given. This time we're given x, and we need to find y. So we are going to do that by taking this equation, 2 times x plus 1, all the way down. We're doing 2 times x plus 1, but we're going to change each time what our x is, right? So this time it's -1. And we're going to multiply. 2 times -1 is -2, plus 1 is -1. And we're going to go all the way down. And all we're doing really is solving this each time. 2 times 1 is 2, plus 1 is 3. You might even notice a fantastic little pattern here happening in this data. And if you do, incredible, you're well on your way. But we are just going to plug these in and solve them. And that is how we find our other coordinate for a solution. So now if we were asked for this solution as a coordinate pair, right? Like this one is -1, -1. And this one is 0, 1. And this one is 1, 3, etc., etc. If you're given a graph and you need to find solutions from there, we're just looking for a point that's on the line. And it's most helpful to look for nice points. And when I say nice, I really just mean one where it crosses right at a nice whole number. Because, if we looked here-ish, there's certainly something, but I'm assuming it's 1.5, but you know what happens when you assume. So we're going to look for nice points that are right on a whole number on the graph. And I have several here, which is fantastic. I have 1, 1, and 2, 3, and 3, 5. And there's even more. What's that? 0, -1, -1, -3, -2, -5. So that's how I find solutions straight from the graph. If you are just asked to find solutions, you have no graph and no table, you're just starting with the equation, you can just pick a number for x or for y, plug it in, and see what the other coordinate is. So let's do that here. Let's just assume that x is 0 and solve from there, right? So 2/3 of 0 minus 1. Well, 2/3 of 0 is just 0, and 0 minus 1 is -1. Boom. We could pick a number for y and plug it in. Let's make it 2 and find out. And now, since I'm starting with my y, I want to make sure here I wrote y equals and I plugged in for x. This time I'm going to plug in for y instead. So I'm going to say 2 equals 2/3 x minus 1. And I'm going to need to solve that for x. So it's going to be a little bit harder this time. I have to get x all by itself on one side. It's not by itself right now. So let's add 1 to both sides. We've got 3 is 2/3 of x. And to get rid of this 2/3, I'm going to start by getting rid of that divide by 3 on the bottom. So I'm going to multiply by 3 on both sides. Got 9 equals 2x, and I'm going to divide by 2. It's not a fantastically round number, but it could be worse. So we can either put this in as 9/2 or we can put it in as 4.5. So when we started with y, we plugged in for y. If we started for x, we plugged in for x. Yeah. When you are given just the equation, and perhaps you have a fractional slope like that one, or a fraction on the x value, it is just easy, just makes your life easier to pick numbers for x that are multiples of your denominator. So let's put in 3 and 6 and -3 and -6, just to make life easy. For 3, I'm going to start with y equals 2/3. And instead of x, I'm going to put in 3 minus 1. And here's the part where it goes nicely. If I take this and I go 2 times 3 is 6. 6 divided by 3 is 2. It happened so nicely. We love it. I don't end up with a fraction, which is fantastic. Let's do it for 6. Y equals 2/3 of 6 minus 1. And I'm going to multiply on the top and then divide the bottom. 4 minus 1 3. So you don't have to do this. We could have easily picked 2, 4, 5 to plug in for x, but when we do that, our answer is going to have a fraction value. And listen, we're great mathematicians. We can solve with fractions. But if you would like it to be a nice whole number, that's why it's nice to use the multiples of the denominator. Plugging in for -3, we have got 2 times -3 is -6. And then we divide by 3 to get -2. We've got -3. And we'll do the same thing for plugging in 6. Multiply on the top and divide by the bottom. -5. So that's how, if you need to find a solution, you can just pick and plug in truly any number you want. But it's nice with a fraction when we use a multiple of the denominator. You'll also see equations in standard form. That's this one here where we have something x plus something y equals some value. And with these ones, again, we can plug in any number we want. So I am going to start with 0 for x and see what happens. So 2 times 0 plus 5 times y equals 20. 2 times 0 is just 0. So now I have 5y equals 20. I'm going to divide by 5 on both sides and get y equals 4. Amazing. One of my points is 0, 4. Now watch what happens when I plug in 1. Just, that was a nice number, but wait and see. They're not all nice. So 2 times 1 is 2. I'm going to minus 2 on both sides to try to get y all by itself. And now I have 18 divided by 5, which, I like that in the fraction form. I would just leave it 18 over 5. But you could put it as 3 3/5 if you prefer, or put it as the decimal if you like the decimal. So we're picking numbers, plugging them in, seeing what comes out. In those first two, we started with x's. Let's start with y's this time. Let's put a 0 and a 1 for y and see what happens. So 2x plus 5 times 0 equals 20. 5 times 0 is just 0. It's gone. Goodbye. 2 times x is 20. Divide by 2, and x is 10. Awesome. So that went with y is 0. We're going to put it right there. Now we're going to try it for 1. 2x times 5 times 1 equals 20. So 5 times 1 is just 5. We're going to subtract 5 on both sides. 2x equals 15. And when we divide by 2, again, I would just leave this 15 over 2. You could put it as 7.5 or 7.5 if that's what you wanted. I like the improper fractions better. So, picking truly any number, plugging it in for x or y, and then simplifying to get x, the other variable, x or y, all by itself.